All right. So we're going to discuss the first. We discussed the first and second chapter in which we did decide what is an engine, what's the construction of the piston engine, and then finally we came on to the basics, how the engine works of the oiling. Okay, how the lubrication part of the engine works. And we slightly told, I also slightly told you that the oil in the engine, of course, after it travels inside the engine, it heats up. So it has to be cooled down. So not only the oil is something that heats up, the other parts of the engine also heat up. Okay, and we need a coolant or we need a cooling system to stop this or to reduce this heat. Okay, so we're going to discuss this good, very good diagram in this picture. Okay, we're not going to discuss everything, we already have discussed all this part. Okay, and what we're going to discuss is this thing, what is this, and if there is another method to use this. Okay, valves, radiator, cooling fan, everything related to this, we'll discuss that. So where and what is this heat, and why do we require a coolant? The piston engine is a heat engine. Its purpose is to convert the energy released by the fuel into the mechanical energy. The thermal efficiency of a piston engine is at best only 25 to 28%. Now I remember telling the thermal efficiency formula. So according to thermal efficiency of the piston engine, it is just 25%. All other 75% is just wasted into heat. We want to reduce this. Okay, this means that 70% of the heat energy released by fuel is wasted. The exhaust gas is responsible for around 40% itself. In the exhaust gas, almost 40% of this heat energy is wasted. Some of this energy can be recovered, and we'll discuss that in turbocharger. Okay, turbocharger and superchargers we'll be discussing in the last part of this segment of piston engines. What are the problems which we face while heating? See, the 32% which was remaining, we had approximately 70%. Okay, if it's not controlled. Such or other problems are structure failure, breakdown of its lubricating properties due to over temperature. What are we talking about? The lubricating properties. Okay, what are we talking about? We're talking about the, okay, I think the internet connection. Yeah, it's back. All right. So I'm talking about the oil. I told you in the previous chapter, if the oil is heated too much, then it could lose its lubricating properties. So this is also important. Finally, there is something new term. It's known as pre-ignition. Now, pre, as the word states, it is before the ignition. We discussed one of the segments was ignition. Now, ignition, if the pre-ignition is prior to the ignition itself. Now, why this has happened? This could happen if internally, if you see, before even the ignition takes place because of the spark plug, if the components inside this area, clearance volume area, okay, exceeds the limit at which the combustion takes place, because already the temperature of these particles are little high. So if that case takes place, then we have ignition before even the spark plug has fired. Now that is known as pre-ignition. Okay. Now, because of the pre-ignition, what happens is not just the particles here have been ignited, the particles which are present in these sections, like in these corners, have also been ignited, and this causes a sound known as detonation. Now this detonation is a constant sound. It keeps on, tuck 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 tuck, it keeps on being having it. So that is known as knocking or detonation. Now knocking and detonation will be discussed in the chapter also. I'll leave it right now. You can see the small video and you realize what I've just told.
Piston sucks the fuel and air mixture into the cylinder through its downward motion.
Induction.
Subsequently, the piston compresses the mixture in preparation for ignition by the spark plugs.
Compression.
The spark causes the mixture to burn rapidly and expand,
Power.
forcing the piston down whilst producing mechanical power that drives the propeller.
Spark. Okay.
The piston once again returns to the top and expels the spent mixture out.
We have the exhaust. But
detonation is the spontaneous combustion of the remaining mixture due to excessive heat and
See?
pressure in the
It's
combustion chamber.
after the ignition.
The rate of energy release is much higher during detonation than normal combustion, which puts the piston under immense sudden pressure. Detonation sounds like pinging, and it can damage the engine.
Knocking. Okay.
Pre-ignition,
This is
on the other
before.
hand, is the ignition of the mixture prior to the spark plug firing. This may be caused by an overheated spark plug or a glowing carbon deposit in the
Okay.
combustion chamber that
Overheated.
ignites the mixture and forces the piston in the opposite direction to its intended travel.
Pre-ignition can break down the engine's components.
Pre-ignition causes immense stress on critical engine components and may result in fatal engine damage.
Okay.
Detonation usually occurs in all cylinders, whereas pre-ignition can occur in one or two cylinders.
At a time.
One sure way to prevent
We'll discuss it
detonation
in the fuel
pre-ignition
chapter.
is to use the correct grade of fuel and to operate the engine within parameters as specified in the pilot's operating handbook.
This will be given to you when you start flying.
If you recognize the symptoms, there are actions you can take to fix the problem before significant damage occurs.
All right.
Excessive engine operating temperature is the key cause of both detonation and pre-ignition.
So heat.
To fix this situation, increase airspeed to generate better engine cooling, open cowl flaps, reduce engine RPM, and set mixture to fully rich.
Okay. This will cool down the engine. So we are now discuss what is the main cause of heat, and we will see how we can reduce this. Problems of too much cooling. Now, yes, we are using a coolant. We're going to discuss if we cool down the engine more than even required, what problems can then occur. Firstly, low temperatures increase the internal friction, hence the lubricant will have a high viscosity. When the lubricant has a high viscosity, this will increase in friction horsepower. I've already told you friction horsepower and reduced brake horsepower. What is the difference? So there is a total horsepower that is equal to the brake horsepower minus the friction horsepower. So if this will increase, then my brake horsepower will reduce. That means that brake horsepower will, okay, I think I written wait. Brake horsepower is this. That. So if my friction horsepower increases, that means that my brake horsepower will reduce. And we don't want that. Why? Because brake horsepower is the power which is spinning that propeller. Okay, if we talk about the propeller, this is the actual usage of the shaft. Secondly, the ability of the liquid fuel to change its state to a gas is reduced, which affects the fuel mixture and combustion. Lastly, to operate efficiently, the engine must operate at a highest temperatures consistent with safe operation. So we require a temperature that should be high, but it should be consistent within the safe operation. We don't want it more cold. We don't want it more hot. We just want it in the middle. Okay. So let's discuss the main topic. Okay. What are the types of coolants? What are the types of cooling systems? Now, first is your liquid cooling system. You all might have driven a car and you might have heard your father telling or engineers telling you, mechanics telling you, the coolant has to be changed. That is the same liquid we're talking about. The liquid cooling system dissipates the heat from the engine by pumping a mixture of water and glycol. Now, glycol is really important here. You need to underline this if you have the notes. Through passages built into the cylinders and cylinder heads. Now, I remember telling you there were passages in the cylinders and cylinder heads. Those passages flow this liquid throughout it. An engine-driven pump circulates the liquid through the engine, and temperature is controlled by a thermostat. Thermostat, I'll discuss thermostat in this chapter only. It's a device to measure the temperature and to control that temperature. Okay, let's discuss what is present in this picture. This is our cylinder block in which we have the piston engines. This is the pump you can see here. It's hidden here. The liquid is stored in a reservoir called header tank. So liquid is present here. Due to the gravity itself, it will help out and it will go into the individual tanks, into the cylinder tanks. Pipes carry the liquid from the header tank to the engine and then from the engine to the radiator back. Now radiator, I'll show you the picture. Radiator is a really fantastic engineering result. Radiator is somewhere where the oil which has where the coolant which just came through the engine, because it is heated up, it will start to cool itself so that it can go back to its header tank. Air flowing through the radiator dissipates the heat from the coolant. The liquid is then passed through an air-cooled radiator mounted on the slipstream of the propeller. So this is mounted on the slipstream of the propeller. What do we mean by that? This. Okay, you can see this. Radiator is present here. Okay, so this is the expansion tank, or whatever you want to call that, a tank in which the coolant is present. You can see that it has been passed into this so that it is started cool. The cool part is also passed here. So whatever the liquid we used to dissipate the heat, now it is already heated up. Now we use this radiator and this present in front of the canopy, I mean in front of the engine, so that when the air is passed, when you're flying, air is passed and this cools. These metal lines will cool up and that coolant will also then cool up. Anyway, other than this, this is already taught to you. Okay, you can see that the coolant goes into these, and there are small linings wherein you can find these linings. This will cool the cylinders. All right. Second type is the air cooling. So you can see here, right? This is a little bit wrong figure. You might not understand this. See, this is just a fan. This is not the propeller. Please don't confuse yourself. It's the fan. It's not the propeller. Who has left us? Abrar. Me, can you please text him? Okay, he's back. All right. So I was telling you that types of cooling systems. The second one is air cooling. Please remember that this is not the propeller. It is a fan. Okay, it's a fan because we are using the air cooling. The air-cooled engine uses the cooling air from the propeller's slipstream. So the propeller must be here. It is passing the air inside. That is the slipstream of the propeller. I think I've already discussed slipstream. I don't have to tell you again. Okay. So what are the advantages of air cooling? It is lighter than the previous one. Okay. And it has less moving parts. Why? Because the air circulates itself and it drops the temperature. All right. These are the pumps. You can see the liquid is present here. The liquid is not required actually. This is the radiator. This is the fan, and the fan gives out inside. It gives you a wind, and when the wind goes flow through all these engines, the heat dissipates. You can see on the top right column also the same thing. Okay. Now, what are the main factors that govern the efficiency of an air-cooled system? Firstly, air temperature itself. That means the outside air temperature we're talking about. Okay, outside air temperature. Now, outside temperature, if it's high, then you can expect the efficiency of the air-cooled system to reduce. If the temperature is less, then if the outside temperature is less, then the air-cooled system will work better. You understand that? It's common sense. Secondly, is the speed of the airflow. The faster you fly, that means that the faster air will go inside the engine and the faster it will cool itself. Thirdly, the cooling fins. These are the fins which I taught you in the previous chapter also. These are also present in the bicycles. The walls of the cylinders are finned to increase the cooling area. This will increase the cooling area. Fourth factor is baffles. Now baffles, I'll tell you what is this. So see, the air is being flown inside the engine like this. Now when it comes inside, so you need to understand that this is high pressure area and this is low pressure area. Okay, so what happens is air goes through this and goes outside. That is how actually, because outside also it is low pressure area. Once these air particles come inside, there is some high pressure area built up. Okay, so they also need it outside. When these baffles do what? They direct this air outside so that they don't get stuck inside and they have a continuous refreshing movement. So at all the particular time, the hot air goes out, the cold air comes in. Okay. Engine construction, engine components are made of materials with a high heat conductivity and aluminum alloys. These have high conductivity of heat. And lastly, we have cowlings. Now you see this is a cowl flap. Okay. Now we discussed cowl flaps in the detonation also video. Cowl flaps or these gills, what are these? These are any disturbance to the design flow which will not only increase drag, but also decrease the cooling. When the cowl flaps or gills open, the airflow over the engine causes pressure drop at the cooling air outlet, thus making it easier for the heated air to flow and maintain a high speed over the engine. All right. So what we're talking about, these are present to increase the airflow throughout these cylinders so that every airflow goes outside. This is a firewall. Now, what do you understand for a firewall? Who can tell me what is a firewall?
It is a type of material which is made stick to the wall. In case of an engine fire, the fire won't break out in the cockpit.
Protection thing.
Good. Both of you are correct. How is the temperature measured? So the individual cylinders have individual CHT. CHT, you understand? It's the head temperature. The pilots can monitor the temperature by knowing the engine head temperature. But you can see, you saw the video, the pistons are moving like this so fast, you can't just install something there and expect to have a wire from this. So instead of that, what we have an electrical component. We have this plug present here. So it measures an electrical sense, okay, electric current on it, and this electric current is passed to the wire, and this indication is then transferred into this reader, indicating as the temperature. You can see here, this is the hot junction, all right. The hot junction has one of these ends, then we have the cold junction, and finally we have the indication. The gauge uses a sensor, as I told you, which is fitted to the engine cylinder heads. If only one sensor is fitted, it will be fitted to the hottest cylinder. Otherwise, it is fitted on the all of the cylinders. In our aircrafts like DA-40s and all the glass cockpit, okay, they have in all of these cylinders. But if it is we can only manage one cylinder, then it will be in the hottest cylinder, which is usually rearmost cylinder. This is really important. That's why I have underlined it. The sensor is a thermocouple. The principal operation of thermocouple is that the sensor produces a voltage which is directly proportional to temperature. I have already told you this, right? Here, the wires are present here. So whenever they sense a temperature, they will convert that into the voltage or current. That voltage or current will be carried forward in this wire, and that will give you an indication on the pointer. The cockpit indication is displayed by a sensitive moving coil meter called galvanometer. I hope you remember class 10th. Galvanometer was taught you in that. It's basically giving you a sense with respect to voltage and converting that into a reading. Okay, the scale reads the temperature, not the voltage. This is the CHT gauge we're talking about, and this is the display. This is the normal operating range. You can see the red function here is the operating limits. After that, you should consider stopping the input for some time. Any questions in this chapter for now? So just a small thing, if engine heats up so much, it can just blast off. That's my not be scared of. Okay. The aircraft is completely safe. Do you have any questions in this chapter? Should we take a break and start the next chapter then? Okay, fine. All right. I'll stop the recording. All right. So let's continue the chapter of sequences. The next chapter is related to this ignition. Now we talk about the spark plug and all. I told you we discuss it in brief. This is the ignition chapter in which we'll discuss how the spark plug works and how is this ignition taking place. You can see the cylinders. Okay. Now as I taught you, there are multiple cylinders present, and in all these cylinders, the pistons are present which are working there. You can see these wires, right? These wires are the inlet of the spark. This is the introduction. Let's go on. Now, till now, you might have considered that there is a single spark plug connection, whichever the videos we're saying, but this is what the reality is. Actually, there are two spark plugs present inside one cylinder. So we're having just there's a backup or for increasing the efficiency. We're having two spark plugs instead of one. We'll discuss the reasons. Okay. An engine has two spark plugs for each cylinder and the two separate magnets. Okay. These are magnetos, not magnets. Sorry. Each magneto supplies power to one spark plug per cylinder. Okay, so one magneto supplies the power to one spark plug per cylinder. Dual ignition system serves two purposes. What is the purposes? Reduces the risk of engine failure. Suppose there's an engine failure because if there's a one spark plug, it could be, if that fails, that means that there is an engine failure. Reduce the occurrence of detonation by igniting the cylinder charge at 2 points. So we saw that the detonation was happening at the corners, or it is the knocking. So if you have two spark plugs, in this case, you can see there are two spark plugs. That means that both at the corners they're having sparks. So the mixture ignites correctly. You can see here, instead of one, you can see this area has not been ignited much. Whereas in this, all the area is mostly ignited. That is the usage of dual spark plugs. Okay. As I was telling you that spark plugs are ignited by, they get a charge from magnetos. Now, if you go back to class 10th and 9th, you will find that there was something known as magnetic induction of voltage by using coils. Okay, the magnetos function as the same thing. Okay, the definition of magneto is they are self-contained engine-driven electrical generators. Now, when we talk about electrical generators, our mind will go directly to the coil system. So this line has been asked in the exams many times. What are magnetos? They are self-contained engine-driven electrical generators. They produce a series of extra high tension electrical sparks at the sparking plugs. So spark plugs is just the outlet, okay, where the spark is produced. This is the back end. Magnetos is the reason they are able to produce the spark. You need to importantly see this line. They are self-contained. They are engine-driven. Okay, so there might be something in your mind right now. If they are engine-driven, then how does the aircraft start? If the engine itself starts the magnetos, then how are they? How is the engine starting? We discussed that, no problem. What is it producing? It's producing a extra high tension spark. The magneto is a combination of the following principles in order to generate EHT voltage necessary to break down the gap between the sparking plug electrodes. There are two things which are involved: the primary permanent magnet generator. The secondary is the step-up transformer. Now, if you remember a step-up transformer, what does it do? It has two different sets of coils. Okay, this is the core coil and this is the outside coil. When there is a gap between them, electric current starts to flow. And when the current starts to flow, and if I have a gap between the currents, there is some voltage. This voltage is taken and supplied to the spark plugs. When the spark plugs finally have this voltage as a spark. Okay. We don't need to discuss all this. We need to discuss contact breaker, magnets. See, magnets are present. Why? Magnets are the things which are revolving and producing a charge. Okay, these are the coils. This is the inside coil. This is the outside coil. And these coils have digits like N and all. This is the number of coils. We will not discuss into the depth. We just need to know the reason why they are present. How does the magneto work in layman terms? The induced EHT voltage is taken to a rotatory switch called the distributor, which distributes the EHT voltage to the sparking plugs in the correct firing sequence. Now, as I told you, the magneto is supplying to the spark plug, but it needs a guidance system. It does not directly get supplied to the sparking plugs. What is the wire which is connecting those things? This is known as distributor. Okay, the distributor, you can see what the distributor does. It basically distributes according to the number, okay, according to the requirement of the cycle. Suppose that you have 4 engines, okay. Now the distributor's job is basically to divide the spark in whichever the engine it is required, in whichever cylinder it is required. If let's say we have the second or the third, let's say third cylinder requires a spark, so immediately the distributor will send out the signal to this. If the second does require it, then this. Okay, abroad. Okay, nothing. So the cam operated contact breaker points and the distributor
Was by mistake.
are geared to, no problem, are geared together so that spark will appear at the sparking plug as the contact breaker points just to. As I told you that there is a contact point and there is a gap. When the gap exists, that is the point the voltage will be produced, or the EHT voltage, extra high tension voltage is produced. You can see here, this video will explain you. See, this is just an example. Okay, this is not the real case. You can see once the charge builds up, okay, the charge reaches its peak. Then there is a gap. This gap has gases. This creates a spark. This spark is carried forward by the distributor to spark plug. The contact breaker cam and the distributor rotor rotate at half the engine speed. You need to understand they rotate at half the engine speed. Why? Because at all the half points we require the ignition, right? First is induction, second is your compression, third is your power, and fourth is your exhaust. Where is the ignition required? It is required in the middle, which is half the point. That is why the contact breaker cam and the distributor rotate at half the engine speed. Okay. Continuing the same thing, you can see in this picture clearly. Okay, you have the ignition system back. This is so this is distributor. This is the second one. So this is your magneto. Okay, you can see what is happening here. Magneto is giving off the charges. Okay, when the charges are when the charges are gone here, this is the distributor. It is distributing into the spark plugs. Okay, according to the requirement, it is changing, and according to the requirement, it will be sending off the charges. The induced EHT voltage is taken to the rotatory switch. There's the same explanation. Doesn't works called the distributor, which rotates the EHT voltage to sparking plugs in the correct frequency. Okay, I have just repeated the same thing. I just wanted to see, make you show with this picture. Right. So this is the video which I wanted to show you.
Magneto.
Same
Let's
thing.
break it down. Let's start with the rotor. The rotor is a permanent magnet.
It's a magnet.
It is rotated by an engine drive gear. Next, we have the coil assembly. Let's
This is
take
the
it apart
coils.
to see what it's made up of. Okay, so in the middle, we have an iron core. Next, we have the primary coil, which is around 200 turns of heavy copper wire. And then we have the secondary coil, which is a 100 times step up, which is around 20,000 turns of fine copper wire. Some important connections that the coil assembly has are first, the hot wire leading from the primary coil going to ground. And also there's a high voltage tab that leads from the secondary coil going to the spark plugs. When the rotor permanent magnet rotates, it induces a continuously changing flowing current in the primary coil, which creates a powerful magnetic field in the iron core. This magnetic field expands outwards, encircling the entire coil assembly. Okay, so when ignition is required, the grounding of the hot wire leaving the primary coil is disconnected. The flow of current is stopped, and this causes the magnetic field to collapse suddenly, cutting across the secondary coil. This induces a huge voltage spike in the secondary coil, around 20,000 to 30,000 volts. This huge voltage spike leaves the secondary coil through the high voltage tab and goes to the spark plug, where the high voltage drives current across the gap in the spark plug, creating the spark required for ignition. Now let's cover a couple of select details before I wrap things up. First detail, the disconnecting of ground on the hot wire from the primary coil is accomplished through breaker points. The contacts are open, disconnecting the ground connection, which leads to the voltage spike in the coil assembly. And the last detail, there is more than one spark plug to consider. Well, this is where
This is the distributor. Okay, so as I was telling you, the distributor has a job to distribute the sparks according to the requirement of the spark plugs. All right. So this is the same diagram. Now I just want to clarify you. This is the magnet that is rotating. You can see there are two number of coils, secondary and primary. Okay. Now when the magnet rotates, it is inducing a charge. Okay, everything is working perfectly. Some charge is present because of the magnetic field present. Now, when you suddenly break Okay, when you suddenly break your charge, you suddenly break this off, the secondary circuit will have a lot of voltage inside it. As I told you, it is known as extremely high tension voltage. Now, when this secondary circuit has the high tension voltage, it has two options. See, it can go to the ground, which is not possible because this is broken. So it has only one option. It will go in this manner and it will go to the distributor. Now, the distributor, what will it do? It will distribute to the needs of the sparks. Okay, this is the basics of your magnetos. There is one other component involved here, that is a capacitor. Now, who knows what is a capacitor? Okay, it's present here. The prime function of capacitor is to prevent burning or arcing across the contact breaker points. Now, why will there will be a burning in the contact breaker points? Here,
Due to excessive heat which is generated by charges, high tension voltage.
uh, yes, okay. What happens is we have broken the contact here. That's where the charge has been produced. But if you see, the distributor is also connected somehow to the contact bit. Why? Because the distributor has to signal when to break the contact, then only the spark will be created. So it is also connected with this. So yeah, you're right about that. It's prevented burning because it could go extreme temperatures because the EHT voltage can cause high temperature. To assist in creating the extra high voltage in the secondary coil by rapidly changing the flux in the primary coil, this increases the efficiency of the magneto. The capacitor is fitted in parallel with the contact breaker points and the magneto control switch. The magneto relies on its operation on the rapid flux, right? Rapid collapse of the flux in the primary coil, and this is caused by the contact breaker points interrupting the current flow through that coil. I hope now it's understood how this charge has been formed. Are we clear with this? No doubts? Right, perfect. So, as I told you, there is one component in whole of this diagram which has to be uh, spun, or it has to be spun by the aircraft. That is the magnet. That's the magnet itself. The magnet has to be spun, so it will require it requires the aircraft's electric power. How will the aircraft generate electric power if it has not even started yet?
Alternator.
Why?
Alternator.
New alternator is after new batch starts. After aircraft starts, then is the only function of alternator will give you. Alternator does what? Alternator actually charges the battery. Okay, battery is present on the aircraft. So alternator, as the engine works on, there's a slight shaft. A shaft has a gear. That gear is connected to an alternator, which charges the battery as the movement of the aircraft. So you are wrong. No problem. So we left with the battery. Okay. So I have already given a clue. So we can use the battery to charge. We can initiate the charge, but this is not sufficient, and I will see why. That is the reason the ignition switch is required. It is fitted in the primary circuit to give control of the magneto. Okay, as I told you, this is the ignition switch. In the off position, the switch is closed. When the ignition is off, the switch is closed. That means it is connected. Okay, so that is connected. And it short circuits the contact breaker. If you see the contact breaker here, it is also connected here. See, this is also not connected when it's off. Talk about off position. Right? Which means that which makes them incapable of breaking the current flow in the primary circuit. So if they're not able to break the current flow, that means what will happen? There is no EHT voltage produced. But in the on position, the switch is open. So the switch is opened. The primary circuit is controlled by the action of contact breaker. Now the contact breaker will also open, that will create the EHT charge. Grounding wire are used to switch off the magneto. You can see the grounding wire is also used here, right? We already discussed the grounding wire. So in the previous picture, I show you, there is a grounding wire. Okay. Now, suppose that if you want to switch off the engine, this grounding wire is used to stop the magneto from giving charges to the engine, and hence there will be no charges sparked in the engine. This grounding wire will, what will it do? Instead of the current flowing here, it will flow here to the ground. Okay. We talk about more of the, see this video. Okay, this is the battery. From the battery, ignition switch, resistor, and this is the coils. Coils charging up, giving it to the distributor. Distributor is distributing the spark plugs. Okay, this is the ignition switch. Ignition switch is charged by the battery. Now, this is a really good hint I'm giving you right now, that it is not with the use of magnetos in the initial set that you are using. Okay, battery supplying power to the ignition switch. Ignition switch itself is giving power. It's giving signal to the magnetos, and the magnetos are then giving their signal to the charge to the distributor. The distributor is giving the spark plugs. Same thing here. I just wanted to show you this video. That's why I've written the same thing here. Okay, the grounding wire is present here as well. If you see, it's not. It should be present here somewhere. It's not present. All right, no problem. Secondary circuit and primary circuit. Secondary circuit, see, it's going to the distributor itself. Primary circuit is the first coil. The secondary circuit is the second coil which produces the EHT. All right, the EHT is produced and given to the distributor. All right. We have magnetos, and you saw how much engineering it requires to build such highly efficient device. Now we need, as a pilot, what can we do? We cannot take a screw and open them whenever you require to check them. Instead of that, we have checks in our cockpit. When we start our engines and we are taxiing, we are on the holding point, or before we taxi, there are different procedures. So we have checks before we take off. What are the checks? When you will sit in the cockpit, you will find the key like this. This is the off position where the key will be when you put it inside. Usually what we have in our cars is we have start, but in this we have right, left, both, and start. What do you understand by right and left? Why is right and left written on the magnetos?
Both dynamos.
Sorry,
Right.
no idea. Okay, first slide, I taught you that there are two spark plugs. Okay, when there are two spark plugs, I told you in the second slide that for each spark plug there is each magneto. So if there are two spark plugs, then there will be two magnetos for each of the cylinder. So we're talking the left and right here. Okay. Anyways, so we have a switch, right, left. It won't start anything. It won't even start on both. What will happen is we have to pull the key to the start, and then the magnetos will start to its job, and then the ignition will start. What happens is when our aircraft has started and we are settled in, what happens? We switch the key, and see, when your key goes to the start, you will, when you leave the key, it will come to both. Okay, it will settle here, and you can taxi and take off. But before we take off, we have checks. We have to check whether our engine is able to sustain on one of the spark plugs or one of the magnetos, the right one or the left one. What we do is, for a few seconds, we go to left, we turn the key to the left, and immediately go to both. What happens is there is a rapid drop in the RPM. We have to check the RPM, and there is a limited check. How much should it reduce? If that is the reduction, that means that it is serviceable. We are good to go. We'll do the same thing for the right, and then we switch to both again. We do it in rapid seconds, I'll say, and we see the RPM change. If they are serviceable, then that should be limits. These are known as dead cut checks. Will be explained here. RPM must drop, but the engine must not stop while switching one magneto off at a time. The magneto drop check is carried out approximately 75% of the maximum engine speed. Okay, we're not talking about the gas. The engine speed is RPM. RPM is this. This checks that the magneto and spark plugs are functioning correctly. They fall in the RPM is due to the increased time taken for the mixture to burn in the cylinders as a magneto. Consequently, its plug in the each cylinder is switched off. Okay, now the question is solved. Do we have any doubts in this now?
No.
Okay. So as I was telling you, the magnetos, okay, during start, most of the aero engines are cranked at about 25 RPM. So when you crank, your propeller spins at 25 rotations per minute. At this speed, the magneto will not produce a spark. It requires a lot of, the magnet has to spin a lot of faster with adequate energy for ignition of petrol and air mixture. Thus, an auxiliary methods of spark augmentation are required. I had given you clues before also. Now comes the picture. These are augmented spark plugs. Okay, these are spark augmentation devices. What do they do? With the help of battery, they capacitate or they contain a lot of energy in them. They contain a lot of voltage in them, and that is sufficient to crank the engine. First is the high tension booster coil, which supplies a succession of high voltage electrical impulses. It is switched on for the starting and off after startup. This ensures that a fat retarded spark is produced in the engine cylinder. As it says, high tension booster coil. We will not go into the details, not required at all. You can just imagine that they have coils. They have stored some voltage inside them, and when you switch the ignitions to both or start, this high tension booster coil gives a push, and the magnetos start to turn fast, and that will produce the voltage. Okay. Second is your low tension booster coil. This supplies a low voltage to the magneto primary during the starting sequence. This system requires a battery supply and is connected to the primary magneto. It is switched on after starting, off after starting. Same thing, off, on. Okay. You can see in this diagram, it's a little complicated, but I will give you the sense what I'm talking about. See the ignition switch. This is the magneto. Magneto has what? Carbon brush distributors. These are the distributors. Now you see what is happening. The high tension transformer is present here, and that gives us reading to the spark plug. It is not the magneto in the initial time. Why? Because the RPM is so low, the magneto itself is not functioning. You need a augmentation device. Lastly, we come to a impulse coupling. Now again, a couple thing has formed. Couple is, moving two things in the opposite directions. This mechanical device uses a spring to temporarily increase the speed of rotation of the magneto, giving a large retarded spark during the starting cycle. No action by the pilot is necessary. So the switches to the ignition. Whenever ignition is put onto both or start, these are spring. They are spring fitted. So when you lose the spring, what will happen is they will spin really fast. When they spin really fast, they will give a push to the magneto, and then the spark will result. These are the three types. These are mostly asked in your exams. We'll see this video and you'll understand the same. Two magnetos, left, right. Okay. Okay, I just pause this video here. Okay. Okay, I can't pause this video. Okay. Yeah, I want to pause this video and explain you. See, I've told you left and right. Now you have to clearly see what is happening here. The left magneto always, there are two magnetos. Okay, you don't have to see that if there are 8 spark plugs, that means that we'll have 8 magnetos. Okay, so in this case, you have to remember this, that the magneto has distributors. Distributors distribute to the individual requirement. So if there's a left magneto, it is supplying to the left spark plug. This is also going and applying here with a spark plug. So if you sit like this, left is here. So you need to consider this as a fact if you are confused till now. Okay. Now let's continue. So let's see this cranking of engine. See, off, both is when they're working.
Fuel and air mixture is ignited by the spark plugs at a precise time in the four-stroke engine cycle. Since the magnetos are mechanically driven engine, they need to be rotated fast enough to generate the current that is necessary.
This is the RPM required. Okay.
startup, however, the electric motor drives the engine.
Approximately 25 to 100.
And the magnetos are also slow. Thus, they generate insufficient current for the spark plugs. You may be tools like this mouse.
This is a coupling one.
It has a coiled spring inside that is attached to the winder,
Okay.
which you rotate to build tension on the spring called potential energy. When released, the spring unfolds and the stored potential energy is converted into kinetic energy, which sets the muscle to adjust all the counts. Back to the engine.
Okay.
Impulse coupling is a device that is used to intensify the ignition spark at slow engine speeds to assist with engine starting. It's built into the one magneto and it's designed to provide a short and sudden acceleration of the motor. When the engine starts, a certain amount of potential energy is stored within the spring. When the coil releases, it accelerates the magneto rapidly to generate sufficient current to create a hot spark. In addition to this, impulse coupling delays the spark. When the engine is not starting but running at normal operating speeds, the spark occurs just prior to the piston reaching the top dead center. This is known as spark ignition. It helps the flame to start moving through the mixture that has been compressed for better efficiency and performance.
Not required so much, but
The impulse coupling delays the spark at startup when the engine is slow to
okay.
ensure the piston is forced by the expanding mixture in the right direction.
Okay, so basics are clear now, I think. Okay. So we'll go to some things which can happen which are not in our hands. One of them is flash over. Okay. We know that the impulse coupling is distributed by the distributor, not the impulse coupling. I'm saying the magneto spark is distributed by the distributors, right? Moisture, if it's present inside the engine due to any reasons, it's also a good conductor of electricity. Why? Moisture, it's not air, it's air with water particles. Okay. So if it's absorbed by the non-conducting material in the magneto, it can create a stray of electrical conducting paths like this. Now you should remember that these are extremely high tension voltage. The high voltage current that normally arcs across the caps of the distributor can flash across a wet insulating surface of the ground and can be misread to the spark plug other than the one they should be firing. Now when this happens, this is known as cylinder misfiring or a flash over. This could result into a condition of engine like this. It could just blast the engine. So we have regular checks, and one of the most reasons we use oiling lubrication to avoid such moisture content to stick up. Okay, so if in case this happens, this would be the engineer's fault, not the pilot's. Lastly, we'll discuss the diesel engine ignition. Now, this is a really interesting thing for me as well, and I found that when I was studying, diesel engine ignitions are not based on spark plugs. They're actually based on detonation. Unlike the conventional spark engine, the diesel does not even require ignition system, thus saving in complexity and weight. That's why in trucks and all these cars these days, whatever the diesel engines have, they're saving a lot of money by not installing petrol engines. The diesel is classified as a compression ignition engine, where ignition of the fuel or air mixture is function of the rise of temperature of air due to compression. What is that in layman terms? Detonation. We'll see this video and understand. Air is only taken. Second stroke. Air is compressed. Temperature rose. Okay. The third stroke. Okay.
The explosion pushes the piston down, which transfers power to the engine. The fourth stroke is to process with spent fuel and mixture access food, access valves, and stroke cycles with heated air. These arrangements is typically 25 to 40%.
All right, without a spark plug. That's the end of this chapter. Okay. So go ahead and read the notes, best source, and of course Oxford books if you're preferring. Do the questions. All right. And yes, if you want, you can stop and discuss the questions Saffron has. Otherwise, you can leave. Saffron, you can stay back and you can discuss the questions. All right.
Yes, sir.
All right.
Yes, sir.